Hi everybody, today we're going to do graph analysis. We will determine the quadratic function that's going to be graphed on a coordinate system. To find the function graphed, let's start by looking at the standard form. We have f of x is equal to a times x minus h squared plus k. On our graph, we can see that the vertex is at the point 3, 1. Let's put those values into our function. Now we have f of x is a times x minus 3 squared plus 1. We need to calculate the value of a by using a second point from the function. For this graph, I'm going to use the y-intercept, that's at 0, 7. I'll plug the values of x equals 0 and y equals 7 into our function. Now we have f of 0 is a times 0 minus 3 squared plus 1, which is equal to 7. When we simplify 0 minus 3, it gives us negative 3. Negative 3 squared is 9. Now I have a times 9 plus 1 is equal to 7. I can move the 1 to the right, which now gives me 9a equals 6. Then I'll divide by 9, which gives me 6 over 9. We know we can reduce that down to 2 over 3. Our graph is f of x is 2/3 of x minus 3 squared plus 1. Let's do that again with another function. Again, I'll start by writing the standard form of a quadratic, which is f of x is a times x minus h squared plus k. In our graph, the vertex is at negative 2, 4. Let's plug that into our function. Now I have f of x is a times x minus negative 2 squared plus 4. Subtracting a negative becomes a positive, so let's rewrite that as f of x is a times x plus 2 squared plus 4. Now I need to use a second point on my graph, and I want to show you a different choice this time than I did in our first example. Notice that we have a line of symmetry through the line x equals negative 2. Notice I have a point at negative 1, 1 that has a horizontal distance of 1 from the axis of symmetry. This point is also negative 3 units down. Because the horizontal distance is 1, I know that I have a value of a equal to negative 3. I went 1 over and 3 down. That's my stretching and my reflection all at once. Plugging in the value of a equals negative 3, I know that my function is f of x is negative 3 times x plus 2 squared plus 4. Remember, you can only use this trick when you have a point that is exactly 1 away horizontally from the axis of symmetry. Let's do one more example. In this graph, my vertex is at the point 3, negative 2. The y-intercept does not occur at an integer, so it's hard to tell what the real value is. Also, when I look 1 to the right or 1 to the left, it's hard to determine the y-coordinate. So what I need to do is find a clear point on the graph where I can see both the x and the y. Let's use the point 1, negative 4. I'm going to plug all of these values into our function f of x is a times x minus h squared plus k. I'll start with my vertex, which gives me f of x is a times x minus 3 squared minus 2. Then I'll plug in that when x is 1, I get a y value of negative 4. That says a times 1 minus 3 squared minus 2 is negative 4. I can subtract 1 minus 3 to get negative 2. I can also move the negative 2 over to the right, which says negative 4 plus 2 is negative 2. Now I have a times negative 2 squared is negative 2. Negative 2 squared gives me 4. So 4a is negative 2. When I divide by 4, I get negative 2 over 4, which is negative 1/2. My overall function is f of x is negative 1/2 times x minus 3 squared minus 2. Remember to look back at your function after you find the value of a. Make sure the sign of a agrees with the graph that you started with.